In the vast, unbroken silence before time began, there was nothing. No stars, no atoms, no directions, no space, not even darkness. For darkness itself requires the potential for light. It was a realm beyond imagination, beyond physical law, beyond language. And then, in a fraction of a fraction of a fraction of a second, everything changed. The universe burst into existence from a singularity, a point of infinite density where the laws of nature as we know them simply ceased to function. Time awakened. Space unfolded. Energy erupted. Reality itself took its first breath. In the earliest heartbeat of existence, the universe expanded at a speed beyond comprehension. This escalation, known as cosmic inflation, stretched quantum fluctuations, tiny ripples in the fabric of space-time, across the expanding cosmos. These microscopic irregularities, frozen into place by inflation, would become the foundation of everything that would ever exist. Galaxies, stars, planets, oceans, and eventually life. The future universe was encoded in the randomness of its birth. As expansion continued, the universe became a swirling, seething sea of particles and radiation. Matter and antimatter collided in violent bursts of pure energy. Yet a slight imbalance. One extra particle of matter for every billion antimatter particles ensured that a small residue of matter survived this cosmic annihilation. That residue would become everything. The universe cooled from incomprehensible temperatures to merely devastating ones. Protons and neutrons formed. The first atomic nuclei appeared. For hundreds of thousands of years, the universe was a fog of charged particles and photon radiation. A brilliant, hot plasma where light could not travel freely. Photons ricocheted in every direction, trapped in the dense cosmic storm. Eventually, as expansion stretched space and cooled this primal fog, electrons finally slowed enough to bind with nuclei. The first atoms formed. Simple, elegant hydrogen and helium. For the first time, light escaped. Photons streamed outward, leaving behind the glowing echo we now observe as the cosmic microwave background. It is a snapshot of the universe as a newborn, uniform, delicate, waiting to evolve. Yet despite this release of light, the cosmos entered a long darkness. No stars shone, no galaxies blazed. It was a transparent, silent universe filled with cold hydrogen gas, drifting through expanding space. And in this darkness, gravity began its patient work. Those tiny ancient fluctuations, mere whispers of quantum activity magnified to cosmic scales, created slightly denser regions in the vastness. Over millions of years, hydrogen atoms drifted toward these regions, forming massive clouds. Invisible dark matter, far more abundant than ordinary matter, shaped the underlying structure. It formed an immense, three-dimensional web, a cosmic skeleton upon which the future universe would grow. The first stars were the universe's next great chapter. Deep within colossal hydrogen clouds, gravity compressed matter until the pressure and temperature at the center reached a critical threshold. Nuclear fusion ignited, releasing immense energy. The universe lit up for the first time. These first stars, known today as population 3 stars, were titans, hundreds of times more massive than the Sun, unimaginably bright, burning their fuel in a cosmic instant compared to the slower, gentler stars that would come later. Their fierce reactions created the first heavy elements: carbon, oxygen, nitrogen, silicon, iron. In their fiery hearts, The elements of future worlds were born. These giants burned hot and died young. Their deaths were spectacular supernovae. Detonations so powerful that they shaped the surrounding space. The shock waves compressed nearby gas clouds, triggering new generations of stars. Their explosion remnants sprayed heavy elements across space. In this way, the universe began to enrich itself, transforming from a simple hydrogen-helium landscape into a diverse chemical playground capable of forming planets, oceans, and eventually life. The cosmic dawn had begun. As more stars formed, they clustered together. Some clusters grew into massive, rotating systems, galaxies. The earliest galaxies were chaotic, turbulent, filled with violent stellar activity. Over billions of years, they grew more structured. Many developed spiral arms, ringed with star-forming regions. Others became elliptical giants or irregular swarms. Gravity, star formation, radiation pressure, and dark matter sculpted these galaxies into the immense cosmic islands we see today. Supermassive black holes took shape in the centers of many young galaxies. Their origins remain mysterious. Perhaps collapsing from the first massive stars. Perhaps forming directly from dense gas clouds. But once they formed, they grew ravenously, consuming matter and releasing astonishing energy as glowing, swirling accretion disks. Some became quasars, bright enough to outshine entire galaxies. These black holes shaped the evolution of their galactic homes, driving winds, triggering star formation, and carving the structure of the cosmos on a grand scale. One galaxy, a modest spiral we call the Milky Way, formed roughly 13 billion years ago. Over time, it devoured smaller galaxies, absorbing their stars into its growing disk. It continues this slow cosmic consumption in the present day, still merging with smaller companions as gravity draws them in. Our galaxy became a glowing pinwheel of hundreds of billions of stars, orbiting a central black hole known as Sagittarius A. Amid this swirling galactic dance, the universe's greatest alchemy continued inside stars. In stellar cores, hydrogen fused into helium. In more massive stars, fusion continued up the periodic table, producing carbon, oxygen, neon, magnesium, silicon, and iron. When such stars exhausted their fuel, they collapsed under their own weight, triggering supernova explosions that scattered heavy elements into the interstellar medium. Even heavier elements, gold, platinum, uranium, were forged in the incredible pressures of neutron-star collisions. Every atom heavier than helium owes its existence to the death of stars. Stars died, but their ashes fertilized the galaxy. New generations of stars formed from enriched gas, and around many of them, orbiting disks of dust and rock emerged. These disks gave rise to planetary systems. Gravity caused particles of dust to stick together, forming larger bodies. Over millions of years, these bodies collided and merged, building planets, moons, asteroids, and comets. Entire systems formed, each with its own architecture, its own story, its own potential for life. Around 4.6 billion years ago, one such disk gave birth to our solar system. At its center, the Sun ignited, a stable, middle-aged star with enough hydrogen to shine for billions of years. Around it, planets formed. Earth began as a molten world, bombarded by asteroids. Over time, it cooled, oceans condensed, and chemistry danced in the waters. Life appeared, simple at first, then complex, then conscious. But the story of life is only one chapter in the universe's vast narrative. Beyond Earth, countless planetary systems circle countless stars in countless galaxies. The universe is so vast that there may be more planets than grains of sand on Earth. And yet, all of this, every world, every star, every galaxy, began from a single cosmic spark. As the universe continued to expand, astronomers on Earth eventually discovered that this expansion was not slowing down, as one might expect under the influence of gravity. Instead, it was accelerating. A mysterious force, now known as dark energy, drives galaxies apart at increasing speed. Dark energy is the dominant component of the cosmos, making up nearly 70% of everything. Its nature remains unknown. It stretches the universe further and further, pushing galaxies away until, in billions of years, distant galaxies will fade beyond visibility. In the far future, star formation will slow. The existing stars will exhaust their fuel and die. White dwarfs will cool into black dwarfs. Neutron stars will drift in cold darkness. Black holes will slowly evaporate through Hawking radiation. Trillions upon trillions of years from now, the universe may approach a silent, cold, diffuse state, a fate known as the heat death. Or perhaps the universe will collapse back into a singularity, or tear itself apart in a final catastrophic expansion, or enter a cycle of endless rebirth. The ultimate destiny of the cosmos remains a mystery. And yet, even as we peer into this uncertain future, the present universe remains a masterpiece of cosmic architecture. Galaxies stretch across the void like glowing constellations on a canvas of darkness. Nebulae bloom in vibrant clouds of gas and light. Black holes warp space-time. Stars forge the elements that compose living beings. Every photon that reaches our eyes is a messenger from the past, carrying the memory of a universe in constant transformation. We look into the night sky, and we see history written in light. We see the ashes of ancient stars, the echoes of the Big Bang, the scaffolding of dark matter, the artistry of gravity, and in the act of observing it, we become part of the story. For the universe has grown not only galaxies and stars but also consciousness. Beings capable of wonder, curiosity, and understanding. The universe began in silence, with a burst of energy and possibility. It expanded, cooled, ignited, built, destroyed, reformed, and evolved. It created the conditions for life to emerge, for minds to awaken, for stories to be told. And now, after 13.8 billion years, the universe observes itself through the eyes of those who ask how it all began. This is the greatest story ever told. Not because it is dramatic or poetic, though it is both, but because it is true. Every atom, every star, every galaxy, every world, every living being traces its lineage back to that single moment when time began. The universe is not merely a collection of matter and energy. It is an unfolding epic, written across billions of years, shaped by physics and chance, illuminated by starlight and curiosity. And the story is still being written.